Let's look at why silicon is preferred in semiconductors. Among the semiconductor materials like germanium and silicon, the extensively used material for manufacturing various electronic components is silicon. Silicon is preferred over germanium for many reasons, such as the energy band gap is 0.7 electron volt, whereas it is 0.2 electron volt for germanium. The thermal pair generation is smaller. The formation of silicon dioxide layer is easy for silicon, which helps in the manufacture of many components along with the integration technology. Silicon is easily found in nature than germanium. Noise is less in components made up of silicon than in GE. Hence, silicon is used in the manufacture of many electronic components which are used to make different circuits for various purposes. These components have individual properties and particular uses. The main electronic components include resistors, variable resistors, capacitors, variable capacitors, inductors, diodes, tunnel diodes, varactor diodes, transistors, BJTs, UJTs, FETs, MOSFETs, LDR, LED, solar cells, thermistors, varistor, transformer, switches, relay and etc. So, looking at types of currents. So, coming to the types of currents in semiconductors, there are two terms which are needed to be discussed. They are diffusion current and the drift current. Diffusion current, when doping is done, there occurs a difference in the concentration of the electrons and the holes. These electrons and the holes tend to diffuse from higher concentration of charge density to lower concentration level. As these are charge carriers, they constitute a current called as diffusion current. To know about this in detail, let us consider an N-type material and a P-type material. N-type material has electrons as majority carriers and there are few holes as minority charge carriers. P-type material has holes as majority charge carriers and electrons as minority carriers. If these two materials are brought too close to each other to join, then few electrons from the valence band of the N-type material tend to move towards the P material and few holes from the valence band of the P material tend to move towards the N-type material. The region between these two materials where this diffusion takes place is called as the depletion region. Hence, the current formed due to the diffusion of these electrons and the holes without the application of any external energy can be termed as diffusion current. Let's look at drift current. The current which is formed due to the drift or the movement of the charged particles, or maybe electrons or the holes, due to the applied electric field is called as drift current. The following figure explains the drift current, whether how the applied electric field makes the difference. The amount of current flow depends upon the charge which is applied. The width of the depletion region also gets affected by this. To make a component function in an active circuit, this drift current plays an important role. There is a necessity to discuss a few important terms here before we move further. What is current? It is nothing but simply the flow of electrons. A continuous flow of electrons or charged particles can be termed as current. It is indicated by capital I or sometimes small I. It is measured in amperes. This can be an alternating current which is AC or the direct current which is DC. Let's look at what is an voltage. It is the potential difference. When there occurs a difference in the potentialities between 2 points, there is said to be a voltage difference. This is measured between these 2 points. It is indicated by V and it is measured in volts. Now let us move to active and passive components. The active and the passive components are differentiated on various factors like nature of the source, its functions, the power gains, controlling the flow of current. Various examples of the component, nature of energy, requirement of the external resistance are there. So let's look at the difference between active and the passive components, which will be as tabulated in the given figure. Let's look into passive components. First, let us know about passive devices. Passive devices or components do not generate energy, but can store it or it can dissipate the energy. Passive devices are main components which are used in electronics, which are together required to build any electrical or electronic circuit. These components do not require any form of electrical power, unlike active devices such as transistors, op-amps and the integrated circuits, which require a power to work. These devices do not provide any gain or amplification, but instead they provide attenuation. So therefore, they can't generate gain or amplify an electrical signal. Passive devices can be used individually or connected together with a circuit, either in a series connection or in a parallel combination, to control the complex circuits or the signals, produce a phase shift to the signal or to provide some form of feedback, but they cannot multiply a signal by more than one because they have no power gain. Depending on their character, the passive components are classified into three types: the resistors, capacitors and the inductors. In both electrical circuit theory and the circuit analysis, passive devices are generally called electrical elements. So let us take a brief look at the three of the most common basic passive electrical elements, namely RLC, that is resistance, capacitance and the inductance. The component values of passive devices such as resistance in ohms or the capacitance in farads are always positive in value, that is greater than 0 and never negative, although some components may have negative coefficients. Passive devices are bidirectional components, that is they can be connected either way around within a circuit unless they have a specific polarity marking such as the electrolytic capacitors. The polarity of the voltage across them is determined by the conventional current flow from the positive to the negative terminal. Let's look at a resistor. If you observe this word, it consists of a word resist, which means to oppose, and resistance is the property of the opposing the flow of electrons. It might be in a conductor or in a semiconductor. So a resistor is an electronic component which has the property of resistance. Resistors functions mainly to control the flow of current and the voltage drops to other components. Therefore, resistors are commonly used to limit current, divide voltages and to pull up input-output lines. For an example, take an LED bulb. Its operating voltage is somewhere between 1.8 volt to 0.3 volts. But the voltage what it is getting from the supply is 5 volts. Then if all the voltage is given to the LED, then the bulb may get short. So the resistor is used to limit the voltage drop across the LED bulb. The resistor is indicated by R and measured in ohms. The schematic symbol of a resistor. All resistors have two terminals, one connection on each end of the resistor. When modeled on a schematic, a resistor will show up as one of these two symbols. Along with the resistance, there are other important terms called as reactants and the impedance. Let's look at reactants. The resistance offered to an AC, that is alternating current, because of the capacitance and inductances present in the circuit can be understood as reactants. When an alternating current goes through a pure reactance, a voltage drop is produced that is 90 degrees out of phase with the current. Depending upon the phase, that is plus 90 degree or minus 90 degree, the reactance can be termed as inductive capacitance or capacitive reactance. The reactance is indicated by X and is measured in ohms. Let's look at impedance. Impedance is the effective resistance to the alternative current arising from the combined effects of ohmic resistance and the reactance. When alternative current goes through an impedance, a voltage drop is produced, which is somewhere between 0 and 90 degree out of phase, which is out of phase with the current. The impedance is indicated by Z and measured in ohms. Classification of different types of resistors. Fundamentally, there are three types of resistors. They are fixed or the linear resistors, variable potentiometers, which is nothing but variable resistors, and special type of resistors. Let's look at fixed resistor. These resistors have fixed value of resistance. The resistance value cannot be changed.